Hello, everyone. Uh, Welcome to our Search and Matching in Microfinance virtual seminar series. Today, we're very happy to have Adrien Devanas to tell us about the deposit business at large versus small banks. So, Adrien, the floor is yours.
Yeah, well, thank you very much for inviting me today. It's a great pleasure to be here. This is joint work with Andreas Feld at UCLA, San Juan at Illinois Urbana-Champaign, and Richard Stanton and Nancy Wallace at UC Berkeley. So what are we going to do in this paper? Well, we're going to argue that the business of raising deposits differ a large versus small bank, and that a key driver of this difference is the heterogeneity in depositors' preferences. How are we going to do that? Well, we're going to use a large database on US bank branches deposit rate and location from 2001 to 2019. And we're going to show that first, large banks are more expensive in the sense that they're going to provide a lower deposit rate to their depositor, but they tend to locate in rich urban area and in general in places with demographic that are generally associated with more sophisticated depositor, so that more sophisticated depositor receive lower deposit rate. We will also find that whenever small banks are in localities where they compete with large bank, this is when these small banks are going to offer a lower rate. And so a model that we try to explain this fact where small bank offer in general higher rate to compete with large bank, that would not work. So we're going to provide a small model with small and large bank location choice and preference heterogeneity. We're going to estimate customer preference heterogeneity for that model and confirm some of the model prediction using a demand system with heterogeneous preference across counties in the US. So we think that we contribute to two blocks of the literature in banking. First, the literature on the deposit franchise value. They generally argue that the deposit part of a bank is very important to understand the value of a bank. What we're going to show here is that the deposit business seems to differ a lot across the distribution of banks, and there's difference and mostly driven by heterogeneity in preferences. I think we also contribute to the literature on bank market power and provide a small framework that can maybe clarify important relationship between market power, uniform pricing, and HHI. All right, let's go into some of the empirical fact. So what we can start with is look at the data through the lens of the RateWatch data set. So there's our deposit rate that they collected weekly at the level of branches in the US from 2001 to 2019.
Adrien?
Yes?
Before you go into details, can I ask what is the conceptual difference between small and big banks that you're thinking of?
So we're going to address that maybe in the framework in a few slides. But in general, we're going to think of large bank as being able to provide a set of financial services that is superior to the one of a small bank. You could think, for example, a larger network of ATMs, maybe access to financial wealth management, or maybe a better online website. In the data, we're not going to be able to really measure these superior financial services, but that's how we're going to proxy it. Did I answer your question?
Yep. Yep, thanks.
So in this data is collected at the branch level from 2001 to 2019. What we can see is that obviously if you control for time fixed effect, you already control for a large part of the variation of this data. But what might be surprising is that if you try to explain or regress this rate on a simple bank times time fixed effect, you explain 92% of the variation in deposit rate. That means that there is very little variation within the bank, so at different branches of the same bank, which may be very surprising, given that in the US you have these large banks that tend to locate in a lot of very different locations. You might think that they might want to explode or set deposit rate more optimally to extract higher profit. So we have that bank set uniform rate across branches. It's not going to be the main focus of this paper. It's actually very well documented by a recent paper by Beguenot and Stafford. Some of the explanation that have been provided in the literature is that it's difficult to set deposit rate at the level of a branch. You need a level of expertise that might be hard to have that level. The large bank might be afraid of complaint about regional price dispersion, and this is related to a G paper that finds something similar in the retail market. And then you might want to avoid internal competition across branches of the same bank that might actually compete for the same depositors. All right, so once we take and we control for the time fixed effect, and we look at the residual variation of this deposit rate after controlling for the time fixed effect, we find again that the bank times fixed effect explain about 90% of the rate variation. That's the same result as previously. But what's interesting is that if you just know where one of the bank is large or small, this is going to already be helpful to explain a significant fraction of this residual variation. And here we're going to precisely define large in the data as one of the 14 large complex bank holding company subject to the Supervisory Capital Assessment Program of 2009. We try different definition of large. For example, take the 1% largest bank in the US, we obtain a very similar result. But the takeaway is that the size of the bank seems to matter to explain the type, the rate of deposit that is set by the bank, and that other demographic indicators such as HHI or population size, while they do appear to actually explain very, very little variation. So HHI might not be a good measurement to try to explain the variation in deposit rate in the data. All right, so this is
Adrien,
just.
can I ask you a question?
Yep. Mm-hmm.
Yep. So, hey, it's Vadim on. So I'm curious at how you selected these particular accounts to look at the checking 2.5 thousand and savings 2.5 thousand, because banks have a lot of different types of kind of similar accounts that they advertise more or less aggressively, potentially in different areas, definitely across time. So kind of how much other accounts are kind of not being selected? Do you know, like, what fraction of the accounts that you're kind of representing here are the bank's business, and so on? Just a little bit more details on those.
Yeah, no, that's a very good question. So here, I am basically limited to what I have from the RateWatch data. The same fact is going to transpire if I look at checking account, saving account, money market account, or certificate of deposits. In most of the rest of the paper, we're actually going to focus on call reports, and we're going to have, we're going to use total deposit, and we're going to have all of the bank that are available in the US. But maybe one thing that you're going at that we're not going to be able to do in this work is study how there might be a competition or assaulting a customer across different products of the bank. And that's something that we're not going to be able to really tackle here just because of the viability of the data. We do not know how much deposit in every location is deposited within each of these categories. This data just does not exist. Yeah.
Thank you.
And Adrien, this is Ing.
Hello.
So
Yep.
the discussion and introduction and all the comments so far are very much framed around the deposit franchise, which is fine. That's one story. But have you thought about like what assets these deposits are financing, to the extent that you might think that there are complementarities on the two sides of the balance sheet, right? You need this funding for this type of asset and so on. Maybe the more direct way to ask is, how do we know that the heterogeneity is not necessarily about the asset side, as opposed to something just in terms of the services or whatever that you have in mind?
Yeah, no, so if you think that there is important complementarities between the asset side and the liability side, and that these differ largely a lot across the type of bank, we might be missing an important channel. And I agree with you. In this paper, we just focus on deposit. We thought that we might try to do this work just focusing by deposit, maybe later work at the asset side. So I'm not going to be able to provide you a satisfactory answer. In the paper, we have some exploration of how the balance sheet between small and large bank differ. We don't think that we have found a pattern or some, something in the data that could explain what we observe. But yeah, that's all I can tell you. Yeah.
Hi, Adrien. And just to follow, this is David. Just to follow up on the previous couple of questions. I wonder if you have looked at the same type of, like in the previous slide, where you have like the large fixed effect. If you can instead look at some form of like the business model of the bank, like what are the sources of the income? I think the story was about the multiple services that some banks provide vis-a-vis the other, but then the categorization is just using size. I wonder if you can explore more, and if you have done it, if you can tell us.
So, I mean, we're going to have a demand estimation system at the end. And in that demand estimation, we're going to have bank fixed effect. So that's supposed to solve from these bank level differences. And the idea of this demand estimation is that we're going to try to convince you that preference are heterogeneous across the US. Okay, and that there's this difference in heterogeneity, or how sensitive some depositor in the middle of the US versus the West Coast, how different this type of depositor are, it's significant quantitatively. And so if you're on board with me on that side, that we can show you this heterogeneity, I'm quite happy with that. That's the main message of the paper. Now, there is certainly a lot of other fixed effect or differences across banks that might also influence part of the variation in deposit rate. I mean, at the end, I will show you that our measure of customer heterogeneity is able to explain 25% of the variation after the time fixed effect. So I think that we attack a significant chunk of the rate variation, but obviously there's certainly a lot of other things to still explore. Yeah.
Thank you.
All right, so this is just a graphical representation just to convince you that small bank offer a lower deposit, a much higher deposit rate than large bank, and that this difference is quite significant. It's about 30 basis points higher on average, which is quite large for this type of products. You can also see that the location of a large bank is quite differs, at least from the small banks. So on this map, I'm just showing you the population density, and in red, there's one red dot for every branch of a large bank. In the US, as you can notice, large banks tend to locate on the coast and on highly densely populated area in the eastern part of the US. If I look now at the geography of deposit rates, what I'm showing you here is the deposit rate controlling for the time fixed effect in these different localities in the US. As you can notice, the middle of the US, which is a very low density population where not a lot of large banks are located, that's where you have the higher level of deposit rate. It's a more highly populated area with higher average income, higher house price, lower average ages, and higher financial sophistication. Overall, these are the areas that are going to receive the lowest deposit rate. So another fact that was
Can I just push you on that? Have you quantified that? I mean, because it's one thing to look at a map, but I can also point out a lot of areas on that map that are sparsely densilated, but that are white, right? So, or light green. So, how do you quantify this map, I guess?
Yeah, we'll come to the quantification, I think, in the BLP estimation. So when we're going to do the demand estimation system, we're going to have one variable that's going to capture the level of income per county, and I'll show you that this is a significant variable, and that helps me explain variation in deposit rate. And I'm going to have a more precise number to discuss later. Yeah. Okay, so I mean, yeah, these are just more motivational empirical fact to motivate the model that I'm going to show you in a few minutes. One last interesting empirical fact is that if you look at the interest rate of small bank and you take the average for different counties and you sort them by the market share of large bank, you're going to find that the interest rate of small bank, that when they compete or when in localities where there is more large bank, that's actually the places where they're going to set a lower interest rate. And so we're going to come up with a model with bank entry decision in the presence of heterogeneous depositor demand to be able to make sense of the fact that I just showed you.
Sorry, Adrien, I mean, regarding this fact, are we talking about like, is there a difference if we split the small banks between like very small ones and like medium regional ones, or is the fact still there?
No, okay, so let me show you something. So this is done with call report, which has a much larger coverage than the call report data. So this is literally 100% of deposit in the US. And as you see, it is this inverted U-shape relationship. And so something seems to be happening for very small bank. What I want to highlight is that the relationship here is negative once you pass there's this weird area with where the cumulative share of this bank is less than 2%. So you're correct that there is more heterogeneity to explore, but here the fact that I show you with the rate watch data seems to be true for the large majority, for 98% of the deposit. Right.
Another question
Yep.
on this rate differences between large and small banks. So you're showing us a graph using rate watch data, right? So it's kind of
This is with rate watch, yes.
Yeah. So it's kind of within product. I think if I were to just do kind of aggregate
this is with call report.
Expense. Yeah. Okay. So yeah, that's exactly right. So you have this kind of opposite pattern going. It's monotonic.
But the pattern is the same. It's just that if you look at less than 2% cumulative share of deposit, there's something strange happening here. But in the aggregate, this should not matter. It's less than 2% of the total quantity of deposit, where the pattern is in the other direction.
Sure. And,
We
and how's
replicate.
it computed? Yep. Sorry, can you just explain again how this is computed over here? The cumulative, the interest rate?
So this is interest expense from call report.
Yep.
Total interest expenses for total call report divided by total quantity of deposit, still from the call report.
Got it.
Yeah. So in general, we actually started steering away from the rate-watch data set because of concern with the quality of this data, and do most of our analysis with call report. So whenever we can, we actually have the comparison between rate-watch and call report in the paper. All right, so let me go to the model. So it's a very simple model that fits in 2 slides. Yes. Yeah, Pablo.
Oh, yeah. So like in any sense of this, yes, this follow, like the products, like the riskiness, so like the deposits, I guess like comparing, so like large banks offering less, a lower rate might also reflect the fact that, the people might have perception of large banks as less risky than small banks. So are these products kind of or is the call report data maybe kind of capturing that, and the rate watch is kind of missing a little bit of that because it's just like a product where you cannot tell whether the deposit will be insured or uninsured, or?
So we have done something where we plotted our measure of depositors' sensitivity to interest rate, and we plotted that with respect to the share of uninsured deposit at the bank. And the relationship between the two was going in the opposite difference, in the opposite sign to explain some of the fact that we have. So if I remember correctly, we found that depositors were more sensitive to rate in banks that had less uninsured deposit. So this flight to deposit or liquidity risk does not seem to be very helpful to explain some of the pattern that we observe. Yeah.
Okay, all right, thanks.
Can you guys hear me? This is Huberto.
Yes, Roberto, can hear you.
Hey, Adrien.
Hey.
Just clarifying in the call report picture, what is each point? Each dot, what is it? What's each dot?
Every dot. So we create 100 bins.
Okay.
Every year. And every year we take the average deposit rate in that bin. and then we take the average across years, I believe.
Thank you.
Yeah. All right, so let me go through the model. So it's a very simple model. We have this indirect utility form. The reason why we choose this form of utility is just because it's going to be very easy to map the model then to the demand estimation system. So what does it say? We have a mass M of depositor I in a given market. They're going to have the option to choose among different banks. So every depositor has $1. It is a mass M of this depositor, and every depositor is going to choose in which bank to deposit that dollar. Now, the utility of depositor I for bank J in market K is going to be negatively related to the spread provided by that bank. So the higher the spread, it means that the bank offers a deposit rate that is much lower than the risk-free rate. So the higher the spread, it's something bad for the utility of the depositor. That depositor is going to have a preference beta for what I'm going to call superior financial services that the bank can provide. So the bank will have the option to invest or not in superior financial services. And then you have the just noise in this preference that's going to be distributed according to this extreme value distribution. The reason why we use this functional form is like in all the BLP literature is such that we have a nice analytical form for the resulting deposit share that is raised by Bank J in market K. Okay, and so we have two important parameters here, which is the price sensitivity, how sensitive the depositor in market K are to the deposit spread, and the value for financial services, beta K. And these are going to vary across markets. Now, from the side of the bank is going to choose whether or not to invest in these superior financial services, but it has to pay a cost, a Chi here, to be able to provide that and maybe to raise the quantity of deposit raised given the preference by depositor. It's going to need to choose in which market to open one branch. So for every market K, Bank J is going to have to decide whether or not it open a branch in that market. And then every bank is going to have to decide on its deposit spread, SJ. Now, there's a very important constraint here that we take from the empirical fact that I just presented, is that every bank is constrained to set uniform deposit rates. So it is forced to set the same deposit rate to all of its branches in which it decides to open. And so if we solve this problem here, which is you gain the spread minus the marginal cost of servicing deposit, you successfully raise this quantity of deposit in market K, and then you have the fixed cost kappa of opening a branch in the market K, and you raise this profit if you decide to open a branch in the market, and then you subtract the cost of having invested in the superior financial services.
Adrien, I think this is where kind of the second point seems like it is a choice by the bank. So you're imposing this external constraint, and I know you motivate it from various frictions in the background, but it just feels like it's a choice variable to the bank, or at least some flexibility about like, do we open a branch and kind of give that branch its own region, so to speak, or some ability to compete on its own, or do we make it kind of operate with our kind of uniform deposit spread that's the same across
No, I mean, I could
right? It seemed just maybe it doesn't make a difference in the quantitative calibration, but this like the first two bullet points just seem like they are related, as opposed to
I agree,
like one
but
being exogenous.
So I think that, I mean, by talking to bankers and people involved in regulation this bank, it seems that the fear or the complaint about regional price dispersion is a very strong argument for why this large bank do not do that. So I don't know how I could have a a credible calibration of that fear or the maybe the arguable cost that would be. But if I had a model and then I want to explain the fact, I would add, the fact that if you have heterogeneous rates across your branch, then you have a small probability of an enormous backlash against your rate. I mean, imagine, especially with some of the political tension of the US, the type of headlines that you could write. You add this risk and then you obtain a corner solution where no large bank decide to do this.
I guess, I mean, maybe it's just an extension, but I know basically I feel like what you're saying is, if I were to play it back, you need some sort of dark matter risk in the background if you wanted the uniform rate setting to be an endogenous outcome. Fair point. But at the same time, it still sounds to me like an exercise worth at least pursuing, maybe in an extension, because it just seems like it would be nice to have the model generate uniform deposit spreads as an endogenous outcome with the branch location choice. And maybe, like I said, maybe it's an extension because for your point, it doesn't make too much of a quantitative difference at the end. But
no, but it's true that I thought a little bit, but maybe by making it endogenous, there's something interesting that will appear in the model. But I don't know because I haven't spent too much time thinking about that point.
One variation on that question is, if in your model where all the banks are doing this, uniform price setting because they have to, if one bank were to deviate and set rates optimally, how much more money would it make?
Yeah, no, exactly. So that's a number we are trying to compute. Turns out to be much harder, but so we have the demand estimation system, and so we can actually compute the actual number inferred by a model, or how costly this needs to be, or how much money is left on the table because of that constraint. I completely agree, and we are trying to get it done.
Yeah, can I ask a question? You're from here. Hey.
Yeah.
Hello, could you hear me? Yeah, sure.
Yes.
So my question is for this chi, right? This parameter that captures how costly it is for you to provide better service. Should we think about it as being the same across all the banks, or is it possible that this parameter itself would differ across large or smaller banks?
I mean, we could add this degree of heterogeneity. I think the spirit of this model here is to be as parsimonious as possible to give you a framework of what we think is happening. Now, I mean, in reality, this cost depends on which technology you're really talking about and what exactly do you mean by super financial services. So to be able to be more detail about that chi parameter, we would need to have accurate or good measurement of the quality of financial services provided by different bank. We don't think that that's what we want to do in this paper, but I think that would be a very interesting research project. Yeah.
Thanks. Can I also ask a follow-up? So do you have any evidence that this service is also the same across all the branches within the same bank? Because I noticed you have XJ there.
No, that's I don't have evidence that it's also quantitatively the same. But that's maybe also something we could try to back out from the demand estimation system to model more accurately the supply side, and then see what the data would imply for the value of this parameter. And maybe we'll find that indeed some of the bank are actually quite inefficient or don't provide such good super financial services or not. All that I need in this model is that I'm going to have a technology that I want to develop that would benefit from scale economies, right? So in a sense, we think that we have some large banks because by being large, you benefit from some economies of scale somewhere, right? And so as soon as we have this, then the model can start. And I think that also encompasses the idea that in a sense, a small bank that works only in one county can really fine-tune its services to the demography and the clientele that is facing, that a large bank maybe do not have that flexibility. But on the other hand, being a large bank allows you to develop things that a small bank cannot.
Okay, that's perfect. I totally agree. So if I may push this a little bit further. So you are saying that this key is this skill or this service has scale of economy.
Yes.
Now I think the model says it's basically perfectly scalable. If you choose a skill, you can apply it to every bank branch that belongs to the same parent bank. Given that this is such an important parameter, is it possible to sort of estimate what is the scale of economy associated with the parameter? It may not be perfectly scalable, but there might be some like scale of economies. Is it possible to pin down this empirically?
I'm sure it's possible. We haven't given enough thought to really answer your question. I would need to think about what could identify that heterogeneity and where we have enough variation, but that would definitely be an interesting thing to try, yes.
Okay, thank you.
Thank you for your question.
Adrien, sorry to slow you down here, but just a couple of remedial questions about the bank's problem. So what is your notion of market? Can you hear me?
Yeah, now let me think at so in the model we just have, that's basically what it's a set of parameter kappa, alpha,
No,
and beta.
like when you take the model to the data, it's like you said county at some point, but
yeah, we'll do at a county level. So let me remember. We're going to construct county clusters. So it's a little bit larger than county.
I see.
Yeah, you would have to look at the detail in the paper because it's been a long time. I haven't looked at it.
I think that look a bit strange, or at least against my intuition, is that you have this dichotomous choice of whether to open a branch in each market or not, but the first order condition is like a first order condition, like if you are taking the derivative of something, whereas here you can only choose to.
Yeah, I didn't show you here the choice with respect to open a market or not.
Oh, okay.
And so this is, as you pointed out, a discrete choice, which is going to complicate a little bit the math. And I'm going to talk about it in one slide. But yeah, to optimize basically this problem, every rank will have to compute the SJ and is XJ for every possible set of decision and choose the one that maximize total profit among all the possible entry decisions. And so we're going to have a free entry condition at the end that pins down the number of banks in each market. I'm going to have a very simple restriction on the set of parameters just to simplify the analysis. So I just reduce the amount of cases that we explore. I'm going to assume that it's too expensive to invest in these financial services for a simple market bank. So basically, there's no such thing as a market that would be large or profitable enough such that spending chi would be profitable for a bank that opens only in one market, okay? And then the result that I'm going to provide below, I'm not going to talk about existence or even claim that there is only one equilibrium. I'm going to provide result that hold for any pure strategy Nash equilibrium. Okay, so the characterization and the proposition that I'm providing you hold for any equilibrium if such an equilibrium exists. So first, we need to deal with the number of single market bank in each market, and this is basically pinned down directly by the entry condition. What's going to happen, and that's because the entry decision is a discrete choice, is that the number of banks that enter might be slightly above or below a threshold or this condition that where this parameter is there to absorb whether I have exactly the number of banks that satisfy this condition or not. Right? The idea is that maybe it is profitable for the last bank to enter, and it might be even profitable. It might be close to be profitable for another bank to enter. But once an additional bank enters, the pie becomes smaller, and then it's not profitable for that bank to enter. Okay, and so this number because it needs to be an integer, there is this parameter theta. And I'm going to assume now that this parameter theta is equal to 0, and that's going to facilitate a lot the proposition that I'm going to present later, because basically I don't need to keep track of these different theta. One thing that is very practical with this theta equal to 0 is basically if I take the numerator of the demands raised by every bank, so let's go down to this equation here. So the numerator here is just going to be in equilibrium a function of the parameter of the market where I raised this deposit, and not a function of the other market that also exists. And so this is going to be a very useful property just to end up with simple conditions. All right, let me show you some of the proposition we have. First, we find that in this model, if you do not invest in the superior financial services, then you must be a small bank, right? The size of the quantity of market in which you open a branch is equal to 1. And so endogenously in this model, we're going to have two types of bank. We're going to have the small banks that operate in one market and do not provide financial services, and then large banks that operate in money market and then provide financial services. We're going to find that when we compare the quantity of deposit raised by small bank to the quantity of deposit raised by a large bank in a given county, that the ratio of these two demand function is basically a function of the spread of the sensitivity of the depositor in that market and the preference for liquidity services. And so small banks are going to compete or increase the quantity of deposit that they raise in a given market by having a lower spread, while large banks are going to be able to compete with a small bank by raising the advantage that they are providing the superior financial services.
Just a quick clarifying question, Adrien. Do the large banks automatically enter all markets, or do they also only enter both? Okay.
Yeah, no, that's a great question, but let me delay it to 2 slides because I'm going to show you this exactly. But actually, that's what this condition is saying. This condition is giving you a condition on which a bank is going to decide not to locate in market K. And so this is basically a distance function. So it's minimized when the ratio is equal to 1 and then increase on both sides. And so that means that if the sensitivity of the market of a given bank is too different from the average deposit weighted elasticity of the bank, then it's not going to invest in that market. And the intuition is very simple. I am constrained to set the same deposit rate everywhere. This deposit rate is going to raise a very suboptimal quantity of deposit in a market where that sensitivity is very far away from the average sensitivity of the market that I service, right? And so I'm not going to disperse myself too much. I'm going to focus on a lot of market that are very similar. But if there is a market that is too dissimilar, this is not a market where I will want to go. And so that's one of the key results of the model. And so here it's not going to be profitable for a large bank to open a branch in a given market if the preference for the financial services is too low, or if the market elasticity is too different from banks J average elasticity. Now just controlling for assuming that market have the same size, the same entry cost, and the same financial preference for financial services, you can just see that if a market is within the set of market where a bank invests, but another market is not in the set where the bank J is opening a branch, then that automatically means that the distance between the elasticity and the average elasticity of the bank is larger for that market, right? And so this is another way to rephrase exactly what I said before. The large bank is not going to open branch in market with extreme alpha, okay? So this, I think, helps us understand some of the features that we observe with the data, and I can create a very simple example. Here I'm going to solve for a symmetric.
Adrien,
Yes.
I have a clarifying question. Can you tell me again in the model, what gets in the way of depositing in one bank and getting the services from another?
Every depositor have to choose one bank.
But it's just by assumption. So
Yes.
I can't bank with, I can't deposit in one bank and get X from another bank. There's no.
Yes. So I think
Sorry, I'm just kind of, you know,
No, you're right. But I think your question goes a little bit to, what is banking nowadays? Nowadays, it's very easy to
But
offer
actually,
money.
no, Adrien, I'm just trying to learn, from your model. In your model, you're not allowing, is it correct to say that
Yes.
you're not considering the possibility of depositing in one bank and getting X from another bank? It's just not allowed.
Yeah,
correct?
That's correct. Yes.
Okay. No,
That's
because there's all these sub indexes, I'm not sure. It's sort of like the J has to be the same.
Yeah, so every depositor has $1 and every depositor needs to choose
on
one
S
unique
and
bank.
on X.
Yes.
That there's a constraint in that problem that the J is the same for S than it is for X, correct?
Yes, that is correct.
Thank you. Thank you.
All right, so let me show you this very simple example. I'm going to solve only for a symmetric equilibrium here. I'm going to assume a very simple distribution for alpha, just a log normal distribution. And there are different objects from the equilibrium that, for the unique symmetric equilibrium that I can solve from this very simple example. So here I have in blue here the distribution of alpha. So I have a continuum of different markets with different alphas. And what I'm showing you, this vertical line here, these are the boundaries that correspond to this condition here, where large banks or banks that decide to open in different markets and not going to open a branch. So if the alpha of a market is below that line, then the large bank is not going to open in this market. If the alpha of a market is above this line, then the large bank is not going to open in this market. And that gives you this idea that the bank, what the large bank is going to try to do is capture as most deposit as possible that they are as similar as possible, right? And so they're going to locate and try to capture all of this market. Now, because they can set only, the large bank can set only one deposit spread, that also means that the quantity of deposit or the profit is going to vary with alpha, right? If I look at the market where the alpha is very close to the average alpha of large bank, then it means that I'm setting almost close to the optimal deposit spread for that market, and therefore the profit of the large bank in that market are going to be very high. When I get away from this average elasticity, average alpha, then that means that in this other market, these large banks are going to raise much less deposit. Now, because small banks are not really constrained, they're gonna set a different deposit rate that can cater perfectly to every different market. And in markets that are more sensitive to deposit rates, so the alpha is larger, they're going to provide a higher deposit rate in order to maximize their profit. And so from this model, we end up with the negative relationship that I discussed in the data before, where the small bank rate is going to be decreasing with the presence or the market share of large banks. And to understand this curve, let's look at the right side of the peak here. At the right side of the peak, as alpha increases, the profit or the market share of the large bank is going to decrease, and at the same time, the small bank deposit rate is going to decrease. And so I have this negative relationship between large bank market share and the deposit rate of small bank. Now you're gonna tell me, but wait, the exact opposite relationship holds on the other side of the peak, where as I'm getting away from the peak, as alpha decreases, we also have large bank profits and market share that decrease, but this time the bank rate, the small bank rate, is going to be decreasing. And so what's going to decide what dominates in the data is whether I have more market on this side of the curve or on this side of the curve, because here I'm going to show you the average. So for every point here, so let's say market share of large bank 10%, which would correspond to that cut here, I'm going to take the average of the rate of small bank in that market and the average of the small bank on that market. And so it's really the calibration that's going to decide in the end whether I'm able to generate this negative slope or a positive slope. So in a sense, the model is not a proof that I always need to have a negative relationship, but this model is able to generate the negative relationship that we observe in the data. All right.
But but it's not related to the part of the core report data that you show that goes in the. So it's this.
No, actually, that's very interesting because this core report data is something that we discovered very recently. And so maybe actually the model could make sense of that as well. But we haven't tested the model yet on that dimension.
Okay.
But yeah, so I really don't know yet. I need to think more about this. So another interesting, yes?
Can you go back to the previous figure, just out of curiosity? If the alpha distribution is bimodal, so you have a lot of mass for very small alpha, a lot of mass for very large alpha, then I imagine large banks were going to be located at the tail. Can you just go through what the other graph look like?
Well, I cannot do that in my head, but so I think if you have a bimodal distribution, you might have some large bank that might decide to locate close to that's going to customize their deposit rate to capture one of the distribution, while another set of large bank might cater to the other set of distribution. I'm not sure that a symmetric equilibrium would exist in that case.
So maybe another way of asking the question is, how sensitive are the results of distribution of alpha?
Oh, this is purely dependent on the distribution and the calibration of the parameter. This is like the result here, well, the intuition that I try to provide for this hold for any equilibrium, but this is just an example, and as I try to emphasize, it's entirely dependent on the parameter that I pick. I don't have a proposition that can tell you what is the set of possible results. I think that's very complicated to generate. Maybe I could try to say for unimodal distribution, this has to be the case, but from me playing with the different distribution, I could generate a lot of different results already just for symmetric equilibrium. And if you have bimodal distribution and you need to deal with asymmetrical equilibrium, this can become very complicated very fast.
I see. Thanks.
Right. Just another insight that we found quite interesting from this model is the relationship between HHI, which is this indicator of competitiveness, and the spread of banks. And to simplify, I think I'm only going to look at the spread of small banks. What I want to show you is that if HHI is varying in the data because there is a variation in deposit rate sensitivity, then the relationship between deposit spread and HHI is going to be negative. Well, if the reason that in the data HHI is changing, is varying, is because of the entry cost is changing, then the relationship between the deposit spread and HHI is going to be positive. To very briefly try to understand this result, HHI can increase, for example, because the deposit sensitivity is higher. If there is a higher deposit sensitivity, that means that there is less money to make in this market. I'm going to have less bank entering into that market. It's going to be more concentrated. And at the same time, the spread of small bank in this market has to be smaller because alpha is higher, because depositors are more sensitive to deposit rate. And so the relationship is going to be negative. Now, if HHI is changing because the entry cost in that market is higher, then I'm going to have less bank in that market. It's going to be a less competitive environment. It's going to be an environment in the most monopolistic competition where small banks are able to increase their rate and benefit from a larger monopolistic power. And in that case, you would observe a positive correlation between the deposit spread and HHI. But all to say is that you should not expect HHI to be a really good measure to explain in the data the variation of this deposit rate that we observe. And I'm gonna show you then a better measure a little bit later that is consistent with our theory that is much more powerful to explain the variation of deposit rate in the data.
Can I ask a HHI question? I think this is a really cool result. So given that you have uniform pricing, I think the relevant HHI should be the average, like for a parent bank. The average HHI for all the parent bank is operating, like the average HHI across all the counties. So if you test it in that way, do you find that this relationship can go either way, or is it like more monotonic relationship?
The relationship can still go either way, depending on what you assume is varying a lot in the data. So you could still find both correlation.
Okay.
So I can generate an example where the only thing that varies across county is kappa, and another example where the only thing that varies across county is alpha, and I would still find the opposite relationship.
Okay.
But you're absolutely right that the proper measure needs to be from the perspective of the bank to explain the spread, at least for the spread of large bank, it needs to be a deposit weighted average. And this is what we're going to build later.
Okay, thank you.
All right, we're looking, so now we're going to measure these different customer preferences in the data. We're going to use the traditional BLP methodology. So we have the indirect utility function. We add some additional bank characteristic here. Importantly, and this is to deal with the irrelevance of independent alternative, and that's basically what BLP is. We need to vary alpha, and we have this shock, this preference shock for different individual. And we're going to also assume that alpha within a market for an individual is potentially going to be a function of the income of that household. So we're going to use supply shock as instrument. So obviously there is a massive endogeneity problem. If you have a bank that provides great services, you're going to observe potentially higher deposit rate. And so it's nothing to do with the elasticity of alpha itself. So we need different supply shock instrument. The idea is that we want to be able to have the supply curve that vary without shocking the demand curve, so that we're able to walk along the demand curve and estimate the parameter alpha. So we're going to use traditional instruments that have been used in the literature. This is not really our contribution here. The relevance of this instrument, what's important is that there's different instrument influence the cost of providing the different service, and therefore the pricing of deposit. The exclusion restriction is that the demand will be insensitive to these different cost changing. All right, so we use different data.
Two questions on the previous slide. So we went from alpha that was market specific to an alpha that now is individual specific.
Yes.
And also the provision of financial services seems to be buried in the big X.
Yes.
Can you unpack this?
I need this alpha to have variation within every market. And this is what basically the BLP methodology is about. And this is to deal with the independence of irrelevant alternative. problem in the demand estimation methodology. I don't think I can give you a good answer in 2 minutes to provide you with the intuition behind why this solves the problem. But basically, it's going to allow for some cross elasticities between different products, such that let's assume that the two products that I need to choose from is blue and red bus, and that the red bus disappear. I would expect all the demand for red bus to suddenly go to the blue bus, right? Because for someone, this is irrelevant where the bus is red or blue. And if you don't have this noise here and there's variability, you're not going to be able to generate the cross elasticities that would be able to generate that. Okay, so that's as best as an answer I can give you on this part. And then you're right that whether I'm a large bank or a small bank is not going to be buried in the bank fixed effect, which is buried in this fixed effect here. And so, we're going to have this bank fixed effect that's going to absorb whether I'm a large or a small bank. I'm going to show you later one parameter that we can properly estimate that tell us something about large versus small. But one of the problem here is that because we do not have a clear measurement of superior financial services, or at least a measure that would be within a bank and varying over time, I cannot go beyond a bank fixed effect. Did I answer or actually help?
Yeah, that was super helpful. Thank you.
Okay, thank you.
Adrien, like you cannot see the income of the is this is some kind of average income in the
We're gonna use this database
in the
of
county
US
is
in the
served
county.
in the yeah okay.
So we're gonna have a distribution. Now, just note that we don't know which household is going to be holding how much deposit at every bank, right? But
That's
that's
what
what
I'm
the
asking.
demand
That's fine.
estimation is trying to square,
Yeah.
right? Yeah, all right. So the data we have, we're going to use a core report deposit rate, FDIC data for branch level deposit balances. We're going to use macro aggregate to proxy for a share of cash, bond, and deposit. We're going to use this consumer household level database for income at the county level. And then we use the standard methodology to converge and find estimates of our different parameters.
But can you show the previous one? The previous one. So is there, so in a way, correct me if I'm wrong, but I'm understanding that in some sense what you're doing is alpha K equals alpha plus gamma INCK, right? Because you're not looking at individuals, you're looking at counties. Or I don't know what counties and markets are.
No,
but
I'm going to have in the BLP estimation, this is done at the individual level. Now I'm going to show you a coefficient here where instead of looking at, but what I can do is make a variation at the average county level. I'm just going to show you another parameter, but in the BLP estimation, it is at the individual level within a county. So
you
there's one.
You can see the income of each individual. No.
Yes. Or I can
can't.
have. It's not everyone. It's a representative distribution of everyone in that county. And
Okay.
so to a certain level, you need to trust that the survey database that has been used a lot is sufficiently representative for the distribution of income in that county. Yes. Okay, so I'm going to end up with several parameters. First, alpha is positive, which means that if the spread is high, then this is something that I dislike. We end up with an average alpha that is quite aligned with other estimates of this average parameter done in the literature. As a reminder, this parameter here, this alpha here, has already been estimated What has not been estimated is how this alpha varies in different localities or in different markets. Okay, and so one parameter that then becomes important is, let me remember, is the gamma here, which is minus 0.5. So what does that mean? It means that if you are a richer household, you're going to be less sensitive to deposit rate. So if we increase the standard deviation, or if we increase your income basically by 1 standard deviation, it means that your alpha is going to decrease by 0.5. So that's quite a significant heterogeneity in these interest rate sensitivities. And so all our thesis is that this heterogeneity is quite large as measured by all the demand estimation system, and is helpful to explain some of the variation in deposit rate that we then observe in the US. We also find that rich households care more about financial services offered by large bank. So we have this coefficient beta. Now this beta, we need to estimate that the market average income is just a question of whether we have the right variation to estimate that coefficient, because arguably beta is firm level, but once we interact whether it's a large bank or not with the market average, we can retrieve this beta. What this beta of 0.015 means, it means that a bank in San Francisco, where the average income in San Francisco is $135,000, can offer a deposit rate of 1.09%, lower than a bank in Champaign, where the average income is $50,000, to achieve the same satisfaction. So again, it is quite significant, right? Between account in San Francisco and in Champaign, I have a difference of 1% in the deposit rate to reach the same level of satisfaction with that estimation of beta. So now it comes to your mind, okay, but now we're saying basically that more financially sophisticated individual and less sensitive to deposit rate. How does that make sense, right? Well, the idea here is that, but that's not something that we can directly measure, but I think that what is happening is that rich households have paid an entry cost to have access to much better wealth saving vehicle, for example, the S&P 500 or stocks. And so the only reason why I have money in my deposit account is for the liquidity that these deposits are providing to me. If Bank of America changes in interest rates by 20 basis points, it's not going to make me change the quantity of wealth that I already put in my deposit bank account, because I don't really care about the interest rate. I don't use deposit as a saving vehicle. If I'm a poor household and I don't have access to the stock market, I don't have better saving vehicle, then I'm literally using the deposit interest rate as an interest and as a saving vehicle, and I will care a lot about the interest rate provided in this deposit.
But Adrien, I mean, I think if you're saying that, there's gotta be data that you can use to show at least the relative to income, like, because you're kind of using income as a proxy for all that story, right? And I'm just saying, okay, can you find a data set where you can see the income of people and their financial positions?
Yeah, I think this has been done in the
right
in the literature already. I'm thinking in particular about the paper by Campbell. I don't have it cited here, but where they do find that richer household and more financially sophisticated, they have access to better financial instrument. They invest much more in the stock market and so on. And so I would suspect that saying that alpha decreases when income increase, you would find again the same correlation with financial sophistication that comes with income.
But Adrien, doesn't that mean that your demand model is sort of misspecified, that you would want to have them allocate between pure liquidity services, checking account, savings, or marginal, like, which would be a money market fund account, but that some agents, lower income agents, just don't pay the fixed cost to have access to a money market account. So then they have all their their savings also in the regular bank account, and therefore that makes them much more rate sensitive.
Yeah, so what I would like is a better model, and this better model would have an additional choice variable, which is not to pay this fixed cost of accessing this other financial vehicle, and then have a different income level for my different depositor, and be able to show that it might not be worth it to pay this fixed cost for a depositor that has very low income and very little savings. But as you pass a certain threshold, or as you become richer, it might be worth your time and effort to actually figure out how to invest better. And that in that case, you would have very little of your wealth invested in a deposit. I think that would be a much better model. That would be an interesting extension. I hope that we can get away with this version of the paper, because solving thoroughly this model and then finding a way to map into the data, I don't think that's going to be very easy. And I think that's also just goes at the message of the paper. I think that if you leave this presentation with maybe the fact that you agree that maybe I showed you that there's heterogeneity in this demand in the US, I'm perfectly fine. I think that's the main message. Now, you want to go at identification, what exactly is the meaning of this parameter alpha and beta? I think we're not going to be very convincing in this version of the paper, maybe.
I was also wondering how then to interpret the evidence on the beta, right? Are you sort of giving banks too much credit for how amazing their financial technology is that's captured by the beta, when really the reason the alpha is low is because rich people have a money market fund, so they don't value the ATM network quite that much. But since in your specification, the only thing that can soak up, or that's how I'm imagining it, can soak this up, is the beta. So it looks like they really value the ATM network, when in reality they do value it, but less, and they have this money market fund account that explains the low alpha.
So what the model would tell you is that if this beta was not sufficiently large bank would not exist. Basically, if there was not a reason for why. So let's remember, a large bank is constrained to set the same rate. And so if you have the choice without a beta, if you have the choice of having one large bank or two small banks, you would always prefer to build two small banks that have some freedom of setting the rate accordingly in both markets, right? And so what the model tells you is that the existence of large bank needs to be backed by some reason why it's advantageous to be large, given the fact that they are so constrained in the type of deposit rate they can set at their different branches. But it's true that it would be interesting to have a way to maybe compare the quantitative magnitude of beta to the magnitude and the variation of alpha. Yes.
Adrien, so we are running a little late. Maybe we can wrap up in a few minutes, then we can continue discussion.
Yeah, let me wrap up in 2 minutes. So this is the estimated elasticities, the alphas. As you can see, the alpha of small banks is much more spread out. It's the small banks that go in the market where the alpha is very large, which help us explain why there's large bank locate in market in the middle of the US with very high semi-elasticities and offer higher deposit rate in this market specifically. We again have this fact where if I look at the average semi-elasticity of bank by the location of where they locate, and I look at market share, I can see that this average semi-elasticity is lower where there is more large banks. So large bank indeed locate in market with lower elasticities where they can charge a higher spread or provide a lower deposit rate. And then I can use our measure of semi-elasticity that we estimate to do exactly the same exercise as before. As you remember, HHI was explaining less than 1% of the variation of deposit rate, but our measure explains more than 20 to 21% of the variation. So it's about 20 times more powerful than HHI to explain the actual variation of deposit rate as predicted by the model, and is also more powerful than knowing whether I'm facing a large or a small bank. All right, in conclusion, deposit business differ large and small banks, and try to argue the key driver is this heterogeneity of depositor preference. Large bank dominant and expensive because they have economy of scales in quality of financial services. Large bank located in rich urban area because they seek uniform demand curves. More sophisticated depositors receive lower deposit rates because richer households are less sensitive to deposit rates. And finally, small banks offer lower rates when competing with large bank because large bank locate in the first place where demand is less elastic. All right, thank you very much.
Okay, thank you, Adrien. Also, thank everyone for participating. I will stop the recording now and allow free discussion.